All right, next up is the malonic ester synthesis. And so here we have our alkyl halide. We're going to add our malonic ester. Or maybe start off with that, flip the reagent and the starting material. And then we'll end up forming a carbon-carbon bond and adding a carboxylic acid. Note that there are 2 carbons added. Let's go ahead and take a look at how this reaction happens. We also do need some base. All right, so we have our base. And then we're just going to do a deprotonation. And in this case, this proton right here is quite acidic because it can resonate with either carbonyl. And so we don't have to worry about using a super strong base. Our sodium methoxide will still cause a complete reaction to the product. Right, then we have this negative charge that is indeed resonance stabilized. But we're not interested in that. We're interested in it doing an SN2 reaction to add a R group there. After that, we do an acidic aqueous workup. Which is going to transform these 2 esters into carboxylic acids that we see on the left. Note that I've rotated the molecule, and you'll see why in a second here. Once you have the carboxylic acids, you apply some heat, and we're going to have an intramolecular pericyclic reaction. That's going to look something like this. This carbon-oxygen double bond is going to attack this proton. This oxygen-hydrogen bond is going to create a carbon-oxygen double bond. And then this carbon-carbon bond is going to break to form a double bond here. And then if you follow along with the products there, you'll notice that this component right here turns into carbon dioxide, which is obviously a gas, and then leaves the reaction. In general, whenever you lose a carbon dioxide, this is called a decarboxylation reaction. It's relatively common in nature. One of the most common examples is like with cannabis. So like if you were just to eat some cannabis flower, it wouldn't really do anything to you. You have to heat it because the decarboxylation reaction has to occur first before the compound becomes psychoactive. And then this enol on the right can tautomerize. Back into our carboxylic acid. So overall, here's what the reaction looks like. We have our malonic acid or ester. Add some base. Again, we don't need a super strong one because the proton is quite acidic. Add your alkyl halide. And then do an acidic workup and then heat that. And you end up adding your R group with your carboxylic acid right there. Right, so this R came from the carboxylic acid. We could do this reaction twice, so you can add up to 2 R groups. Right, we've got 2 acidic protons there, 2 alpha protons, so we can replace one of them or we can replace both of them, just depends what you want to do in the order in which you do everything. So if you have your malonic ester, you can add your base, add your R1 group, add another base, add your second R group, and then do your acidic workup and heat to do the decarboxylation. Right, and so again, these R's came from our 2 steps. in general, it doesn't matter which R group you add first, right? You don't have to add like the bulky or the non-bulky one first. It doesn't really matter. And again, this step 5, that's the hydrolysis. So turning those esters into carboxylic acids, and then the decarboxylation, losing a CO2 group from a carboxylic acid group.